Imagine a world where the impossible becomes routine, where technology doesn't just make life easier, it transforms the way we live, work, and connect. Today, we're diving into the technologies that will change the world forever, breakthroughs so powerful they will reshape industries and rewrite the rules of science. From AI that thinks faster than humans to energy solutions capable of powering entire nations sustainably, these innovations aren't just ideas. They are real, they are coming, and they will touch every part of our lives in ways most of us can't yet imagine. Let's explore. Micro-modular nuclear reactor. Micro-modular reactors are engineered for rapid deployment to remote communities, island grids, industrial facilities, and critical infrastructure where compact, carbon-free energy is needed most. Because these systems are primarily in development and certification phases worldwide, specific commercial pricing is not yet publicly fixed, though early estimates for factory-built units capable of around 5 megawatts suggest capital costs are competitive with diesel generators when life cycle fuel, maintenance, and carbon costs are factored. Unlike large power plants that take years to build, micro-modular reactors are factory-fabricated and scalable, producing between 1 megawatt and 20 megawatts of electrical output depending on design and configuration. Size with typical portable units aimed at around 5 megawatts electric. These reactors are fueled with low-enriched uranium enriched to less than 20% U-235, which supports continuous operation for 5 to 10 years without refueling. inventions microreactor. inventions microreactor is a compact, transportable nuclear power system engineered to deliver clean, reliable electricity where traditional grids are unavailable or unreliable, transforming how remote communities, industrial sites, and critical infrastructure access steady baseload power. It produces continuous output up to 5 megawatts electric and is designed to run at full power for 8 or more years without refueling, offering a carbon-free energy source built for long-duration missions. Factory-assembled and modular in design, the inventions microreactor can be shipped by rail, barge, or truck and installed above ground with minimal site disruption, giving it rapid deployability and scalability for off-grid power needs. Its advanced heat pipe technology replaces complex coolant systems and eliminates pumps and high-pressure circuits, reducing points of failure while increasing passive safety and reliability. At roughly the size of a small industrial module with a footprint well under 2 acres and transportable enclosure-style construction, the inventions microreactor pairs seamlessly with renewables such as wind, solar, and hydro, and can serve hybrid energy systems or standalone baseload roles. It also produces usable heat for district heating or industrial processes in addition to electricity, giving operators flexible energy options on site. Tesla Optimus Gen 3. Tesla Optimus Gen 3 is Tesla's next-generation humanoid robot designed to walk on 2 legs, manipulate objects, and assist with real-world tasks using advanced artificial intelligence and autonomous systems. Standing roughly 5 feet 8 inches tall, it features hands with 22 degrees of freedom, enabling nuanced manipulation and human-like dexterity across a wide range of chores and operational roles. Built for practical utility, Gen 3 runs Tesla's neural networks, the same core technology behind full self-driving, allowing it to perceive complex environments, maintain dynamic balance, and navigate spaces autonomously. It moves at a normal walking pace of about 5 miles per hour and can lift between 40 and 45 pounds, making it suitable for factory assistance, household support, and commercial deployment. Tesla has redesigned its actuators and sensors to reduce weight while improving precision, giving the limbs and hands more natural grip and agility than earlier prototypes. A built-in battery pack supports extended untethered operation, enabling consistent performance throughout a workday. Agility Robotics Digit. Agility Robotics Digit is a bipedal humanoid robot engineered to work alongside humans in warehouses, factories, and logistics environments, handling physically demanding tasks with AI-driven precision. Standing about 5 feet 9 inches tall, Digit's 2-legged design allows it to navigate human-centric spaces, stairs, aisles, thresholds, and workstations without requiring any facility modifications. Digit's dynamic walking system, paired with advanced sensors including LiDAR, stereo and RGB cameras, and inertial measurement units, provides balance and fluid motion even in cluttered or uneven environments. Its embodied artificial intelligence integrates machine perception with motion planning and whole-body control, enabling it to react to surroundings, adjust footing, and manipulate objects autonomously. Equipped with articulated arms and specialized end effectors, Digit can grasp and move totes, boxes, and other payloads up to 35 pounds. It walks at an efficient pace of around 5.5 miles per hour, supports autonomous docking for charging, and can operate within larger automation systems alongside other robots. Digit's mobility and payload capacity come from a lightweight build of approximately 143 pounds made from composite materials, while its unique leg design inspired by animal biomechanics enhances stability in constrained spaces. Battery systems provide several hours of operation per charge, minimizing downtime and maximizing productivity. Xpeng Iron Robot. Xpeng Iron Robot is a full-sized humanoid robot, blending advanced artificial intelligence with highly articulated motion and industrial design to perform real-world tasks in commercial and service environments. Standing about 5 feet 10 inches tall and weighing roughly 154 pounds, it incorporates a bionic spine and synthetic muscles that enable fluid, human-like movement through 60 to 82 actively controlled degrees of freedom across limbs and torso, with exceptionally dexterous hands featuring 22 degrees of freedom per hand. Its core computing system uses multiple in-house Turing AI chips capable of around 2,250 trillion operations per second, supporting perception, navigation, voice interaction, and adaptive behavior across complex tasks. The robot runs on all-solid-state battery technology that provides enhanced safety and higher energy density compared with traditional lithium-ion cells, enabling multi-hour operation on a single charge. Integrated sensor arrays provide 720-degree vision and environmental awareness, and dynamic navigation systems allow Iron to walk with balance and avoid obstacles while carrying a payload of up to 20 kilograms. Projected pricing for units of this class is roughly $150,000, with mass production targeted for late 2026 as the platform transitions from prototype to commercial deployment in roles such as retail assistance, reception guiding, and light logistics support. Eurodrone. The Eurodrone is a next-generation European remotely piloted medium-altitude, long-endurance aircraft system designed to deliver persistent intelligence, surveillance, target acquisition, and reconnaissance capability with multi-mission flexibility and strategic autonomy. It is the first major European male remotely piloted aircraft system built to fly reliably in civil and military airspace, giving European armed forces a sovereign unmanned aerial capability developed by Airbus Defence and Space, Dassault Aviation, and Leonardo for Germany, France, Italy, and Spain. Engineered as a large twin-turboprop male RPAS with a wingspan around 98 feet and overall length near 52 feet, the Eurodrone carries a maximum mission payload of roughly 5,070 pounds and can remain aloft up to 40 hours depending on mission profile. Its dual Avio Aero Catalyst turboprop engines enable cruise speeds up to about 500 km per hour, and a service ceiling near 40,000 feet supports long-range surveillance and wide area coverage. Sail Drone is a fully autonomous ocean surface vehicle powered primarily by renewable wind and solar energy. Engineered to sail the world's oceans, collecting high-resolution atmospheric, oceanographic, and environmental data without human intervention for extended missions. Its fleet operates continuously for more than 12 months, delivering persistent environmental intelligence and robust situational awareness across climate research, maritime security, weather forecasting, and defense missions where traditional crewed platforms cannot safely or economically operate. The Sail Drone Explorer class measures about 23 feet long with a wing height near 15 feet and a draft of 6 feet. and its patented hard-wing sail harnesses wind power for propulsion, while solar panels energize onboard systems, so it can cruise at about 1 to 3 knots while gathering data around the clock. Its autonomy and renewable propulsion let it remain at sea for more than 365 continuous days without resupply, enabling long-term missions over vast ocean regions with unlimited range. Saildrone's advanced sensor suite combines precision meteorological and oceanographic instruments that measure wind speed and direction, barometric pressure, air and sea surface temperature, humidity, salinity, dissolved oxygen, chlorophyll levels, and sea surface currents, giving scientists and decision-makers real-time, high-fidelity environmental data straight from the field. Radian 1. Radian 1 is an advanced single-stage-to-orbit spaceplane under development by American aerospace company Radian Aerospace, engineered to take off and land like a conventional aircraft and reach orbit in a continuous flight that eliminates expendable rocket stages. It is designed to transform access to low Earth orbit by combining horizontal runway operations with full reusability and rapid turnaround between missions. Radian 1 measures about 120 feet in length with an 85-foot wingspan, and its wing design leverages aerodynamic lift in ascent while reducing thrust demands compared with traditional vertical rockets. So the space plane is engineered to launch from a 2-mile-long rocket-powered rail sled that accelerates the vehicle to high speed on a runway before the onboard rocket engines assume power for orbital insertion. The vehicle's architecture supports 2 to 5 crew members, or an equivalent combination of personnel and cargo to orbit. It can carry up to 2,270 pounds of cargo to low Earth orbit and return up to 4,540 pounds of downmass, providing exceptional flexibility for resupply, scientific research, in-space manufacturing, and other mission types. The internal payload bay offers approximately 93 cubic meters of usable volume for equipment and experiments. Europe's future space transport. Europe's future space transportation vision centers on evolving a reusable, modular, and sustainable system, enabling dependable access to low Earth orbit and beyond, backed by initiatives led by the European Space Agency and partners across industry. This ecosystem includes development of reusable rocket technologies such as the Themis prototype, a reusable first-stage launch vehicle testing vertical takeoff and landing capabilities, and the Space Rider reusable orbital spaceplane, which will fly payloads to orbit and return to Earth with minimal refurbishment between missions. These efforts build on Europe's Vega C and Ariane launch families while integrating next-generation propulsion like the Prometheus liquid methane engine to reduce launch costs and environmental impact. The broad strategic objective encompasses reusable boosters, in-orbit logistics, payload delivery, orbital refueling, and standardized interfaces that allow a mix of vehicles to operate together as a sort of interoperable space logistics network, supporting commercial ventures, scientific missions, and collaborative international space operations. Parker Solar Probe. Parker Solar Probe is humanity's closest mission to the Sun, built to study the outer solar atmosphere and solar wind in unprecedented detail. Traveling at speeds exceeding 125,000 miles per hour, it passes within 3.83 million miles of the solar surface, gathering critical data on solar plasma, magnetic fields, and energetic particle emissions that directly influence space weather and Earth's environment. The spacecraft is protected by a carbon composite heat shield capable of withstanding over 2,500 degrees Fahrenheit, allowing its instruments to operate while exposed to extreme solar heat. Its high-precision sensor suite measures electric and magnetic fields, plasma waves, and energetic particles, transmitting real-time data back to Earth for analysis. Parker Solar Probe flies in highly elliptical orbits, while gradually moving closer to the Sun over a 7-year mission while enduring intense radiation and thermal conditions. Launch mass is approximately 1,517 pounds, solar arrays extend 7.3 feet at full deployment, and onboard power reaches around 395 watts. Together, these systems enable continuous scientific observation, helping scientists better understand solar storms, energy transfer, and the dynamic behavior of our closest star. As we wrap up, remember that accuracy isn't just about specs on paper. It's about engineering, design, and the perfect synergy of every component working together. The rifles we've explored set the benchmark for what's possible when craftsmanship meets performance. If precision, reliability, and sheer engineering excellence excite you, these platforms redefine the standards of shooting. If you enjoyed this breakdown, make sure to like the video, share it with fellow shooters, subscribe for more precision-focused content, and drop a comment telling us which rifle impressed you the most.